That was a perfect segue for a reminder I wanted to share with everyone. As Scott mentioned and talked about how federated sidechains work and the powerful flexibility that they enable for XRPL, we are pleased to remind everyone that today we announced Wave 2 of the XRPL Grants program. Those are open and live. For this wave, the focus area is going to be on federated sidechains. So if you'd like to build a sidechain or experiment with adding new features to the XRPL, please learn more by going to xrpl4j.org. Next up, we'll get a deep dive of the XRPL programming with Neil Hartner and Noah Kramer. Neil is a senior staff software engineer at Ripple, and Noah is also a software engineer at Ripple. Neil and Noah will discuss how XRPL4j and hooks can function together. Neil and Noah.
Wow, it's great to be here. It's kind of sad that we're getting near the end of the Apex conference. I was kind of thinking, what if I could do like Ted Cruz did in the Senate, where he filibustered and just read Dr. Seuss stories so that you couldn't leave? But I think I'll avoid that. So I'm Neil Hartner. I work at Ripple. My sidechain for this presentation will be Noah, or actually maybe I'm the sidechain because he's bigger than me. But yeah, we're going to be talking about XRPL4j, which both of us, Noah and myself, are contributors to. We'll be talking about that along with hooking that into the new hooks proposal. So just to give you an overview, we're going to take a little bit of time to talk about hooks. We'll look at what it looks like to write a hook. And then Noah will go into an overview of XRPL4j, some of the features. And then we'll look at using XRPL4j to actually deploy a hook that we will write here onto the network, and then he'll speak some more about some features coming up in XRPL4j. So we've got a demo prepared as well. Will it be a success? We'll see. It depends on some network stuff that at the last minute we seem to be running into, but we've got a recording as a backup. OK, so what are hooks? It's a proposal by the XRPL Labs. It's supposed to be kind of a lightweight smart contracts. What does that mean? It means that you can't do everything you can do with a full smart contract, Turing complete. But we're hoping that, like a lot of times in development, you can get 90% of the value with like sometimes 50 or less % of the complexity. So it's definitely less complex than something like an EVM, but hopefully it's something that can deliver most of the value that people are looking for from smart contracts. And it's basically code that you attach to an XRP ledger account. And this code gets triggered when transactions come into or are leaving an account. The hooks are written in, they compile down to WebAssembly, and there's a couple ways that you can write WebAssembly. So there's a WebAssembly script language. You can also use C. Rust also has a way to compile to WebAssembly. And just want to point out, this is still kind of an early proposal. It's in beta testing right now. There is a hooks testnet, but it is still very early beta. OK, so let's talk about what hooks can do. They can look at transactions that are coming in. They can look up information about that transaction. They can decide whether or not they want to accept or reject that transaction. There are some hook SDK functions that your hook is allowed to call. This will allow you to do things like generate a new transaction. You can store data that's specific to your hook. You can also look up data that was stored by another hook. And we'll get into some examples of like where that might be useful. And there's also, I think this is still being developed, but the idea of having multiple hooks on an account where they get chained together, where a series of hooks could be run in sequence. So let's talk about what hooks can't do. As I mentioned, they're intentionally not Turing complete. And David Schwartz kind of alluded to this earlier, that there's costs to being able to have a full Turing complete language that turns it up in gas costs, execution time. So to keep it lightweight, you can't do everything with hooks. For example, you can't loop indefinitely. You don't have access to unlimited storage. I want to say it's 64K of data that your hook can store. You can't, just like with other smart contracts, you generally can't call outside to external systems. You can only look at data on the ledger. You can't create your own user-defined functions and call them. So when we go through the demo code, you'll see that you're given one function that you can implement. You can't have helper functions, so that the reason for that is so that it's easy to determine that your function can't, have infinite recursion or can't run forever. But it does limit you to, everything has to be in one function. You also can't directly call other hooks, though you can emit transactions that may cause a hook attached to that account to trigger. And likewise, you can't update hook data on another account. You can update your own. You can read another hook's. It's kind of like that old joke about your friends and picking nose. Like you can look at their data, but you can't update their data. Okay, so some examples. Joseph earlier mentioned a couple of these. I'll just touch on them again. So you could do things like a carbon offset, where when money comes in to your account, you might want to set aside, whether it's a charity donation or a carbon offset, you could take part of the money that's coming in, or maybe when you pay out to somebody, you could emit a transaction that sends some amount of that payment to another account. You could do allow denialists, like maybe you're a bank, you're only allowed to accept payments from people that you've KYC'd, and therefore you know their XRP ledger address. If you get an incoming transaction from them, you may not want to accept that. Maybe you're not allowed to hold funds for them. You can reject that. Pooled accounts, this would be the idea that you could have multiple. When you make a payment on the XRP ledger, you can put a tag onto that payment. It's possible you could use that as a mechanism to say, well, how much money has each tag received? And that's sort of a way of like partitioning or pooling the money to see, well, this amount was for this tag, and maybe that tag has meaning to you. You could also think about using this to manage hot and cold wallets. So let's say you have a hot wallet that you're sending and receiving payments from, but you don't want the balance of that hot wallet to ever exceed, say, 10,000 XRP. And let's say you get a big payment that comes into your hot wallet. You could have your hook trigger and say, okay, my balance is going to exceed 10,000, so I want to take anything over that amount, and I'm going to forward it to my cold wallet account, and that account's not accessible, so that's kind of a nice way that you don't have to have a server constantly watching your transactions on the ledger and making sure to move that money off when that happens. And then just generally DeFi, I mean, that's a broad term. But you can think of things like automated market makers. I've heard some people in the community contemplating how they could build an automated market maker using hooks. So kind of the sky's the limit there. For this demo, I thought it might be interesting, since we're in Vegas, could we build a slot machine into an XRP ledger account? And if we think about a slot machine, if we boil it down to its basics, it's essentially something that accepts money and has a variable rate payout and a variable, so it pays out at various, I guess sometimes it might pay out, sometimes it might not, and then when it does pay out, like there's a variable payout. But when I was listening to the NFT talks, I thought, like, why would you do this? Like, why build a slot machine like this? Like, it's kind of a demo, but, like this slot machine will have an advantage over other slot machines in that it runs on the XRP ledger. So the XRP ledger is always up. It's always been up since it's launched. And so our slot machine will always be accessible. Users of this slot machine will know exactly what the rules are of it. So they'll know, like, is the payout rate, does it pay out 98%? 97%, whatever, because when you upload your hook to your account, that is in the clear. Everybody knows what your hook is. They can go look at your GitHub repo or wherever it is that you're hosted the code that generated that hook binary, and people can validate that, yes, this hook attached to that account has this behavior. And if you've done something like black holed your account, that's a way to prove that I threw away the keys to this account, therefore the state of this account will not change. I'm not allowed to go update the hook. Like, you wouldn't want a hook where, oh, awesome, this looks like it pays out 200%, so I definitely want to use it, but by the time I send my transaction, the owner of that account has replaced that hook with another hook that never pays out. But if I've black holed the account, then I know that whatever hook is on there, that I will get that behavior. We could even do more interesting things like, a slot machine, generally you put in money and you get out money or tokens. But what if this was a slot machine that paid out NFTs, and maybe you didn't pay it, like you would put XRP in, depending on how much you put in, you would have a probability of getting some NFT. Maybe there are more rare ones, and so you have a chance of getting the more rare ones, sort of like a loot chest in some of these virtual games. So I think there's some interesting things just to think about, like how this could be an improvement over the real world. So with that, we're going to do a demo. I'm going to walk through some hook code. OK, so we're on the screen here. OK. So this is code that an idea I came up with. Richard Holland is really kind of the brains behind the hook proposal. So most of this code is code that I butchered and took from him and then adapted myself. But we'll kind of walk through it just to kind of get an idea of like what does a hook look like if you were to write one. At the start, you have two functions you can implement. One is called cback and one's called hook. The cback function gets called, like as a hook, you're allowed to emit a transaction. If you emit a transaction, and that once that transaction is accepted into the ledger, you get a callback to say, hey, that transaction you sent, it was accepted, and maybe you want to do something once that emitted transaction is accepted. For this demo, it's empty. I'm not doing anything. We're only going to look at an incoming transaction, and we want to do something on that. So let's pretend that we're a slot machine, and we're on the XRP ledger. So the first thing I'm going to do is I want to know who I am. So payment has come in. I want to look up what is my account ID on the XRP ledger. So when you look at this is the C code. And unlike Java or JavaScript, you deal with a lot of data types that aren't maybe as familiar in more modern languages. You deal with pointers. You deal with copying data in between buffers and arrays. So that's kind of what's going on here is that we declare a variable to hold the account ID. We call this hook account method. That is one of those SDK methods that the hook API provides for us. So we're allowed to call those methods that it provides, but nothing else. So this is a method where it's going to look up the account ID of the transaction that's currently triggering, and it's going to copy it into this buffer here for the account ID. If for some reason we can't look up the account ID of the hook, we're just going to give up. So rollback says, I want to reject this transaction. I don't know what to do with it. Give up. OK. So next thing we want to do is transactions could be either a payment coming into my account, or I could be paying out to somebody who has tried to play the slot machine. So I only want to pay out when somebody is paying me, right? So I don't care about if I'm paying out to somebody else. So I'm going to look up who is the source of this transaction. Is it me or is it somebody else? Again, I'm going to look up the source account. I'm going to get this field from the transaction. If it turns out, here we're going to check if the source account is me, meaning the hook, then I assume that's an outbound transaction. I'm going to accept it. At this point, the hook stops executing. That transaction is accepted, and it will move on. OK. Now we're going to get to, all right, we think we've got a payment coming into us, but with XRP transactions, you have XRP payments, but you also have issued currencies. Let's not deal with issued currencies for now. Let's assume our slot machine only accepts XRP. So what we're going to do is, again, declare a variable to store the amount. We're going to take that transaction field for the incoming transaction, put it into our buffer, and it just so happens that when you have an XRP payment, the amount field will be 64 bits versus if it's an issued currency, it'll be 384. So we're just detecting that if we got something that doesn't look like an XRP payment, it looks like an issued currency, we're also going to roll back and say, sorry, this slot machine doesn't take issued currencies. OK, so now we get into the maybe like usually a slot machine, like you can't put $1 million into it, you can't put a penny into it. I thought, hey, let's make it such that if you're going to pay into the slot machine, it has to be an amount between 1 and 100 XRP. So again, this is kind of repeat the same thing. We're going to end up looking up how much the amount was in drops. If it turns out that the amount was greater than 100 drops, we will reject. If it's less than 1 drop, we'll reject, so that payment won't go through. Otherwise, okay, now we're to this point where we think we have a payment that's 1 to 100 XRP. Therefore, we need to decide, are we going to pay out as the slot machine? First thing we have to do is we have to signal to XRP Ledger that we are going to emit a transaction, that we intend, not in addition to the transaction that's coming in, we intend to create another transaction. And we want to have kind of this variable rate payout. So the Hooks SDK gives you a function to generate a nonce. A nonce is sort of like a random number. We're just going to use a nonce and hash it. That will give us a bunch of random bytes. We'll take, down here, on line 55, we'll take the first byte in that nonce. It's going to be, since it's a byte, it's going to be a value between 0 and 256. We will hash it with the number 21, which will give us a number between 0 and 20. And if you divide 20 by 10, that becomes 2, which in percentage is 200%. So this is all to say we're going to generate a random number, and we want it to be something that's a multiplier of 0 to 200%. So if you get a 0%, that's basically like you didn't win anything. If you got 200%, then you're going to double your money. Just to make sure that they're aware, like our hook didn't just die or like did what it's supposed to. If it's 0, we're going to give you 1 drop. You'll always get a drop, even if you didn't win. And lastly, now that we've decided, we know how much we want to pay out. We know who we want to pay out to. We need to look up how much this is going to cost the hook to emit a transaction. So this is still being worked out, but there's the notion of like, well, how much should the hook have to pay? Similar to like gas on Ethereum. This is sort of placeholder of your hook is going to have to pay some fee in order to emit a transaction. So we'll get that fee there. And now we're going to go ahead and prepare a payment. Again, this is using another method from the Hooks SDK. We've got the transaction, we've got how much we want to send, the fee, and then who's sending it. These other ones are for tags. I just put the tags to 0. And then finally, at the end, we are going to emit the transaction, which means it's going to put that transaction for our slot machine payout into the queue or into the next open ledger. So the payment that's coming in will be accepted in the current ledger. We're going to queue up a payment for the payout that's going to go into the next ledger, assuming the account has funds to pay that out. And then at the end, we're saying, we're done, we're accepting this payment, we've emitted our other payment, and this, if you were to look at the RippleD logs, you would see a log message saying that it hit this point. So once I've done this, so I've got this C code, and I need to now turn it into a WASM binary. The way you do that is, since this is C, I have a makefile here. You can look at what the makefile is going to run. We can even run that ourselves. So I installed a tool called, I think it was WASI-env, W-A-S-I-E-N-V. Once you install that, it installs this WASM compiler that will compile a C file into a WASM file. If I run that, it runs the compiler. I get a little warning. I think that's OK. Yeah, that's fine. And now if I look at what's here, it just generated this vegas.wasm file. And that's the thing that we're going to have to put on the ledger. So with that, I'm going to turn over to Noah, and he's going to take us through taking this hook and actually deploying it.
Thanks, Neil. So yeah, we have this hook just laying around on our computer. It's not really doing anything. So how can we actually take that WASM and deploy it to an account? Enter xrpl4j. There we go. So xrpl4j, just some background, is a Java library for interacting with the XRP ledger. I actually have the advantage of going third of all the client library presentations, so I don't have to say too much. But we released in January 2021. Neil and I do some maintenance on it. But some of the main features, just like Python and JavaScript, you can do wallet generation and derivation. You can sign transactions. You can serialize to and from XRPL binary. You can also, we also have model objects that map to some of the key XRPL primitives like transactions and request response objects. And you can serialize to and from JSON using our Jackson module. And then lastly, we also have a client that uses the JSON RPC API. That's still in beta. We sort of went quick and dirty with it when we first built it and haven't gotten back around to it. But more on that later. So why don't we write some code? I'm going to use xrpl4j to actually submit our WASM hook to the ledger. All right, so just to sort of orient us, I have an IntelliJ window open with a file, just has a main method so that we can run it. I'll also be showing everybody the XRPL hooks testnet explorer so we can take a look at some transactions. And then lastly, I just have a RPLD node with hooks enabled running locally in a Docker container. And so first thing you want to do is just create an XRPL client connected to, and this is my locally running RPLD node. And then we're also just going to create a wallet factory that we can use to generate new wallets and derive wallets from seeds. So we actually have this cool vanity account, our Vegas 8er. And so I have the seed for that. So I'm going to just restore that wallet so that I can sign a transaction and attach the hook to that account. So I'm going to use my wallet factory from seed method. And let's see. I have the seed here. This is test, so I'm not too worried about you guys seeing it, but we'll call that the Vegas wallet. And then the next thing we're going to want to do is get that Vegas wallet's account info from RPLD. What that's going to give us is the current account sequence that we can attach to the transaction. So I'm going to use the XRPL client account info method, and that just takes some request params. So I'll use some request info params and use the Vegas wallet classic address. I should also mention that a wallet just consists of a public key, private key, an address, and that's it. So we'll call this the Vegas account info. And we're also going to want to get the fee that's currently on Ledger, so we can do that using the XRPL client. And then last thing we need to do is actually read our WASM file into our program and encode it as a hex string. So I have this handy dandy method that'll do that for me. And I can just point it to a file. I'll point it to our Vegas WASM file. So we'll call that WASM hex. And this will just be, again, the WASM file encoded as a hex string. And now we can start constructing our transaction. So I'm going to create a set hook transaction. And we can use the builder to actually build it. And so we'll start filling this out. So we're going to need an account, which is, again, just the Vegas wallet classic address. We're also going to need the fee that we fetched from RPLD. So we'll take that, and we're just going to use the open ledger fee so that our transaction goes through relatively quickly. Also going to need the account sequence, which will come from the account info, account data sequence. And the set hook transaction uses this field called create code, where you simply just attach a string with the hook hex code. So I'll pass in our WASM hex, and then also our signing public key, which again comes from the wallet. All right, now I think the only thing left to do is actually submit the transaction. So we're going to take the XRPL client and use the submit method, which takes a wallet and our transaction. And what this will do is take the private key from our wallet and sign the transaction that we supplied, and then submit it. It doesn't do any reliable transaction submission. It doesn't wait around. But I think that's all right, because we can just look on the Explorer and wait for it to get validated. So I'm just going to log some stuff out so we know what's going on. So I'll log out the engine result, which we can get from the submit result. And then I'll also just put in a link to the Explorer page. And I have that. And we can also just use the hash that we get back from the submit result. So if I run this, it should work if everything goes well, if the demo gods are kind. And we should be able to look at the transaction on the testnet Explorer. All right. So we have this link that'll take us to the Explorer. Make this bigger for everybody. So you can see that our account is our Vegas 8er. And then this create code is just our WASM code, again, encoded in hex. And yeah, set hook transaction, basically all the regular transaction fields. And we can see that it got validated pretty quickly. So let's see if this part works, because we were having some trouble earlier. But I'm going to open my Sum app. And I have an account. I'm connected to the hooks testnet in Sum. And I have just an account with some XRP in it. So I'm going to send, I don't know, I'm feeling lucky, so I'm going to send 100 XRP, send it to the Vegas account, and not working. Let's see. I do have a recording. There we go. All right, so start again. Have my Sum app open and have some XRP in it. And I'm just going to send 100 XRP to our hook-enabled account, our slot machine. And so I have that account saved already. All right, and slide to send. Thank you, Sum. And it should go through pretty quickly. And I think I do actually get some money back on this one. So if we go to our past payments, we can see that we sent 100 XRP to our Vegas hook. And the slot machine gave us back 50 XRP. So we lost some money, but that's OK. I think we'll get lucky next time. So yeah. That's how you can use XRPL4j, in this instance, just to set up a hook on an account. But again, you can use XRPL4j to do pretty much anything you'd want to do on XRP Ledger in Java. So what's next for XRPL4j? One thing that I'm really excited about, because it's come up a lot in our work at Ripple, is adding a new signing library to the toolkit. You know, for a lot of instances, a lot of applications, it's OK to have keys in memory. If it's a relatively hot wallet, you don't need that level of security. But for other applications, you might not want to store those keys in memory. So what we want to do with our new signing library is enable applications to actually use something like an HSM or a hardware device to sign transactions, and just adding that extra level of security. And then, of course, we'll have NFT support. And along with that, we are planning on actually rewriting the XRPL client to support all of the RippleD methods. One thing, I don't know if anybody's a Java developer in here, but one of the things with Java is that there are a lot of different HTTP libraries that you could use. And we didn't want to sort of force developers to use the one that we thought was best. So we're hoping to allow developers to bring their own HTTP clients and still be able to use the JSON RPC API with some sensible defaults, of course. And then last, we've noticed things that we do a lot, and they're pretty boilerplate. Obviously, we still want to allow developers to do those things themselves, but for those that don't want to, we want to provide them with some higher level API methods, such as transaction autofilling, or similar to what you saw in the Python SDK, things like get account balance, things like that. So just want to thank you all for coming to Apex. It's been awesome meeting everyone, and I'll see you around.